Hey everyone. In this video we need to make quite a bit of preparation for before we actually create a table. So be on the lookout in the description for a script I will give you that will call the data type creator process that we created in, I believe, the third video. And what we're going to do is we're going to define all of the columns in a table, but first we need to create those data types to match. So that will be this video. You have a script that you can run to create them, and during the SQL portion of this video I will be explaining each one and their purposes. So hope you enjoy.
Alright, so I created a table creator prep card under the prep maintenance label, and it's just to, note that we're going to be creating a ton of data types in this video. Short video, lots of talking, so I'll drag that into doing, and let's get started. Alright, so we have a ton of user-defined types to create, and I'm just going to call them UDTs from here on forward. And I don't want to spend a lot of time describing what the purposes of these columns are, especially in some of the other ones, because we'll cover that subject in great detail later on in the series. Right now, it's just focusing on getting ready to create that table. And about 90% of these are needed for that table. So the first UDT is the primary key. Every table will have a primary key. The next UDT is a tenant ID. And every table will have a tenant ID, which is basically who owns that record. Right now it's going to be 1, which will represent us. It'll be the first record in the group table. So we can think of it as leasing space in our system. Instead of creating new objects and new databases for a client, we can house any application, anything in one data structure. The next two columns are for the taxonomy. The realm class family type, which you'll learn a little bit about in the next two videos, but once you start using them, it'll make more sense. The table structure is realm class family type, and then an unmarked table I just refer to as the base table. The base has a type ID, type has a family ID, family has a class ID, class has a realm ID, and the realm has no ID above it. So we need a taxonomy ID for every table but the realm, and then a cluster ID for the realm itself, because it's a very important piece to the physical model. Next we have the descriptor columns, which describe the row. And we do not really want to show most of these to the outside world. For example, the name is meant for our internal use. We're naming a record. It has nothing to do with a person name, even though a person table or a people table will have that name in it, a name column in it. It won't represent a first, middle, or last name. It's just identifying what the record is, not for consumption. Same with the description, describing why the record is there. Abbreviation, because when we refer to MDM, what does it mean? It really helps get rid of tribal knowledge. So that's why the abbreviation is there. Column header is meant for dynamic pivots. And we may not use it on every single table, and it may be null most of the time, but we will find cases where we wish we had it, so we're going to add it in there. The key name is one of my favorite columns and possibly the most powerful column in the system. The key name will always be uppercase, and if it's not null, you don't change it. When we create functions, we will be calling records using the key name only. So our code's going to look really clean, and in future videos you'll see what I'm talking about. Next couple columns are the ordering columns. One ordering column for integer or numeric values, and another one for text. The sequence really stands out when we're working in relationship tables, because our relationship table can store direct descendant and ancestor relationships across all domains in one single table. The sequence helps us determine distance from the parent. Also, order in which we, could return that row or process something. And the display order is just the textual version of that for those rare cases that we need some sort of textual version. And I didn't make it that big because we don't want to store data there. We just want to use it for a specific purpose. Next up is the physical model. Now, the specific data set number is kind of like an object ID for the system. No data set, file, view will have the same number, but in every table, it will be the same number for every row. So in one table, it could be all ones, in another, it'll be all 87s, but you will never find a repeat. This is a huge piece of the physical model and will be the first field in our cluster indexes to keep everything close together in the same page, extent, what have you, which will really increase the speed of our system. The specific dataset number implied and primary key implied are meant for our relationship tables, so we can say, hey, this is a specific dataset number that came from a different table, and this is a primary key that came from a different table, which in turn allows us to relate any table to any table in one structure. And just because we're talking about specific dataset number, I need a data type to represent the source of that dataset number, and I will go over that later. So we have a cleaning system in every single one of our tables also. It is comprised of a primary key and a flag. So the flag represents whether you can clean this or not. Perfect example is geography. We don't want to clean a very nice country, city, state dimension. However, any incoming data we may want to clean, and the cleanse to will help us redirect that incoming data elsewhere. So someone can type Oregon, G-U-N, and we could just clean it to the proper spelling. And every time we get Oregon, it will automatically reroute and get the appropriate ID. System flags, pretty basic for the first three. The active flag, which is, is this row active or not? Trusted flag, do we trust it or not? Is it something, from the government that we can, accurately trust, or is it from a client that always gives us bad data and we don't want to mark it as trusted, or some sort of web scraper? So that's what that trusted flag's for. Archive flag, we do delete records from our system, but if we think about the taxonomy, if we archive a type, the archive flag tells us that any type or any base record that was attached to it has been moved to the archive database, so we can easily undo that action, or at least make a decision when we run into that. The other 4 system flags are the data management system flags. If you remember back from the introduction to the series, we have 4 databases that sit outside the loop. So every single row in our system can have parameter-based security, and that's for the security flag. A plan flag says that this row is going to experience some sort of action at a point in time, because the plan database will contain the data information, whether we're activating it, deactivating it, trusting it, removing it, whatever, preloading data, expiring data. That plan flag being one tells us something's going to happen. Display flag is for our user-facing content translated by time of day, language, gender, geolocation, whatever you want. If a row has a display flag of 1, that tells us that it has some sort of user-facing content. And another flag tells us that this row has additional information, essentially, like development notes. We had to put a note on this that didn't really fit in the description, or row GUIDs, so we don't have to run into the problems that you have when you define an actual row GUID, which will also help us overload GUIDs using the same GUID on different records to create a relationship without actually creating a relationship. And the last 2 flags that I'm going to have in here for today are the foreign key, which is different from the foreign key parent. The foreign key just being a foreign key, but the foreign key parent has a specific definition. And the easiest example is we're going to be creating the database and dataset tables in the next sprint. And the data set has a foreign key parent of a database. So that is they do mean two different things, and that is kind of why we are normalizing what we're looking at. A foreign key is, whatever, but we can take a decision on if it's a foreign key parent. Well, let's use that column name and go look at the parent table. Oh, it has a parent. Let's recurse and keep going until we find the source of the of a tree. So that is basically it for this episode. All of this are in the description below. You can download this script, so please download it and run it so you don't have to do all this typing. I'll make you do typing for the other pieces because it's actual logic, but right here it's unnecessary. So enjoy this script, and in our next video we will be creating our first table since we're ready to. Thank you again and hope you enjoyed. I will see you next time.